Okay, welcome to the lesson on acids and bases. So far, we have categorized chemical compounds as either being covalent or ionic. Compounds can also be classified as an acid or a base. Acids can sometimes be identified by their chemical formula. The chemical formula for an acid usually has an H written on the left-hand side. So for example, HCl is an acid, and we know that because there's an H on the very left-hand side. AQ next to the acid means that it's dissolved in water. It's only when HCl is dissolved in water does it actually become an acid. If it's a solid and it's not dissolved, then it's not considered an acid. Acids release hydrogen ions when dissolved into water. An example is HCl. It's an acid found in your stomach to help you digest food. The chemical name is hydrogen chloride, and the acid name or the common name is hydrochloric acid. So when you dissolve HCl, hydrogen chloride, into water, the compound splits apart and forms H plus ions and Cl negative ions. Once this happens, this then represents the acid HCl as an acid. Other examples of acids are found in the table below. I'm not going to go through each one of them. You can read it for yourself. But what you have on the left-hand side is the chemical formula. Then you have the chemical name, so the name of the acid, and then a common name and some examples. So for example, the formula for hydrochloric acid is HCl. The chemical name is hydrochloric acid, and the common name is referred to as muriatic acid, and it's produced in the stomach. Bases release hydroxide ions OH negative when dissolved in water. An example is NaOH. So you can recognize a base by looking at the chemical formula. If there's an OH on the right-hand side, then it's probably a base. There's no special naming system for bases. So when NaOH dissolves in water, it produces Na plus ions and OH negative ions, and then it becomes a base. So here you have some examples of some common bases, their chemical name, and then their common name, and some examples. So acids versus bases. Acids are sour, corrosive, and they conduct electricity. Corrosive means they can eat through things like metal or even the tissue of a person's hand. So you have to be very careful when dealing with acids. Bases are bitter, slippery, and they're also corrosive. They can burn through skin or even metal. Some common images you will see on a container with an acid or a base are the following. So you see a hand that's being burnt through, which could represent an acid or a base that's corroding the tissue of the hand. And you have a picture here where you have some acid or base that's corroding, could be a block of wood or metal, and a person's hand. So these symbols both mean that the product is corrosive. pH scale. A pH scale is a number scale for measuring how acidic or basic a solution is. pH below 7 means that the solution is acidic, as seen in red here. Anything below 7, So 6 to 0 means it's acidic. A pH above 7 means that it is basic. And a pH of 7 right in the middle means that it is neutral. Each decrease of 1 on the pH scale indicates 10 times more acidity. For example, a pH of 4 is 10 times more acidic than a pH of 5. A pH of 3 would be 1,000 times more acidic than a pH of 6. So the lower you go on the scale, the more acidic the substance becomes. And the higher you go on the scale, the more basic it becomes. The closer you are to the middle, the closer you are to being neutral. pH indicators. pH indicators are chemicals used to determine how acidic or basic a solution is. pH indicators change color based on the solution they are placed in. Two colors of litmus paper, blue represents basic and red represents acidic. A pH above 7 would be blue. So red litmus paper will turn blue in a pH above 7, and below 7, blue litmus paper will turn red. Universal indicators contain many indicators that turn different colors at different pH values. A pH meter uses electrical probes to measure how solutions conduct electricity. Many natural sources such as beets and cabbage are also indicators. So here's a table with some common pH indicators. So litmus paper is red at a pH, this represents 7, 0, and 14. So right in the middle, you have a neutral solution. Blue stays blue and red stays red. To the right of that, red will turn blue if it's a pH above 7, and blue will turn red in a pH below 7. But the litmus paper can tell you only if something is acidic or basic. It can't tell you the pH, or in other words, it can't tell you how strong the acid or base is. You have to use the other indicators to narrow down the pH range and figure out how acidic, how strong the acid or weak the acid is. So let's take methyl orange, for example. Methyl orange, excuse me, at a pH of 3 or less is going to be red. At a pH of about 4, just over 4, it's going to be yellow. And between 3 and 4, it's going to be a combination of red and yellow. It's going to be orange. And that's why you have a diagonal line indicating that it's a blend of the two. So the line is diagonal, it's not straight up and down. And the same works with the other indicators as well. So you have to use several indicators together to narrow down the pH range. And we're going to do an activity tomorrow showing how exactly that works, where you'll use some pH indicators. Some common household items and their acidity level or how basic they are is shown here. So for example, milk is acidic. It has a pH of about 6, so it's not highly acidic, but it is acidic. Hydrochloric acid, the stomach acid found in your stomach, is very acidic at a pH of 1. The reason why it doesn't burn through your stomach is because you have a layer of mucus that protects the stomach. And you can see here that most household cleaners are basic. Production of ions. Acids and bases conduct electricity because they release ions in solution. Acids release hydrogen ions, H+, bases release hydroxide ions, OH-. The pH of a solution refers to the concentration of ions it has. So the square brackets means concentration. So a high concentration of H plus means it's very acidic and it has a low pH. A high concentration of OH minus means it's got a high pH and it's very basic. A solution cannot have both H plus and OH minus. They cancel each other out and form water. This process is called neutralization. So when you combine an acid with a base, it produces water, and we say that they neutralize each other. So you can often if you combine an acid with a base, you basically produce water. And this is a summary of some properties of acids and bases. That concludes the lesson. You do not need to take this quiz. You can move on to the worksheet questions.